Hello and welcome to another exciting video. So this question says we should find the resistance of a meter wire of diameter 0.2 millimeters and resistivity 44 times 10 raised to the power of minus 8 ohm meter. Alright, so let's start by writing our solution. Now let's observe this question carefully. It says that we should find the resistance. So we are looking for resistance. Let's start with that. R is question mark. And then they say of a meter wire. So we know that the length of the wire is 1 meter. And then they said the diameter is given as 0.2 millimeters. So D is equal to 0.2 millimeters. And that's converted to meters because that must be converted to meters since this is in meters. So 0.2 times 10 raised to the minus 3 meters, right? That conversion milli means raised to the power of minus 3. Okay, that's 10 raised to the power minus 3. Then they say the resistivity, and we know that resistivity is given as rho and is equals to 44 times 10 raised to the power minus 8 ohm meters. Okay, so bringing out this value, we know that this is related to resistivity is Ra over L. So since they ask us to look for R, then this equation tends to R is equals to rho L over A, making R the subject of the formula. So if this is that, then we are given rho, we are given length, but we are not given area. How do we get area? Now this is a wire, and we know that a wire has a circular end, right? So we will represent a wire like this. It has a circular end. So they say the diameter of this wire, that's from a point of the circumference to the other, passing through the center exactly, is diameter. And they say that diameter is 0.2 times 10 raised to minus 3 meters, right? So if that's that, then this is a circle. What is the formula to calculate the area of a circle? So this is going to be area of a circle is equals to pi r square. This can also translate to pi d square over 4, depending on what you are comfortable with. If you are comfortable with pi r square, then this diameter, you have to divide it by 2 to have radius. Since diameter is 2 radius, therefore radius is diameter divided by 2. So you have to divide the diameter by 2 first, then you put it into this equation, you still get your answer, or you just use the diameter directly into this equation, you still arrive at your answer. So my own choice is to use it directly. So area will be equals to pi d square over 4. Pi is given as 22 over 7. Otherwise, it can be given as 3.142. And then our d 0.2 times 10 raised to the power minus 3 raised to the power of 2, all divided by what? 4. So area will be equals to 22 over 7 times. This square will affect this value and will affect this. So we have 0.2 squared times 10 raised to the power minus 3 times 2, all divided by 4. This is going to give you 22 over 7 times 0. When you are giving 0.2 square, it's just same thing as 0.04 or 1 over 25, anyone you want to use. And I can just use 0.04 times 10 raised to the power of minus 6 all over 4. So let's multiply the numerators together. So this is going to be 22 times 0.04 exponential minus 6, right? So we have 8.8 times 10 raised to minus 7, all divided by 7 times 4 will give you 28. So let's divide this value by 28. So we are having 3.1428 times 10 raised to the power of minus 8 meters squared, because that's area, that's the unit. So if this is gotten, then we'll put it into this equation now, this one, to find the resistance. So R will be equals to rho L over A. Rho is 4 times 10 raised to the power minus 8 times length is 1 meters, all divided by area 3.1428 times 10 raised to the power minus 8. So by division, 10 raised to the power minus 8 will cancel 10 raised to the power minus 8. So you are left with 44 times 1 will still give you 44 all over 3.1428. So your resistance is going to give you what? So let's divide 44 divided by 3.1428. So we have 14.00025 ohms. So resistance does not have this kind of crazy value. So our R is equals to 14 ohms. So that's the value of our resistance. Okay, so we're going to wrap it up here. I'll see you in the next video. Bye for now.